Hi class, in this lecture here what we want to do is we want to talk about all the properties of logarithms, and what I'm going to do in class or in this lecture today is I'm going to introduce the properties, and then this lecture is just going to be a ton of examples of working with them. So what I encourage you to do is try pause the lecture as I put up the problems, try them on your own, and then then unpause the lecture and watch as I do it. Okay, so let's talk about what we're gonna work through here. So we're gonna introduce three rules for logs. We're gonna introduce something called the product, the quotient, and then the power rule. And I'm gonna show you how to use all these rules. And then what we're gonna do, we're gonna spend a lot of time talking about how you expand logarithmic expressions and then how you condense logarithmic expressions. So there's gonna be a lot of great examples there. And then the last thing we're gonna do is I'm gonna talk about how you use what's called the change of base property. Okay. So let's start with the product rule. It's very simple. All right, so let's let b, m, and n be positive real numbers with b not equal to 1. If you have log base b of m times n, so this would be something like this. I'm going to do some examples here. Let's say log base 4 of 5 times x, okay? What you're allowed to do is you're allowed to take the log and break it up. Okay, you can write this as log base b of the first factor plus log base b times the second factor. So this right here, this would be my m, and this would be my n. And what I'm saying here is this is equivalent to, it's equal to, log base 4 of 5 plus log base 4 of x. All right, and I'm going to show with the calculator. I'm going to show you how this works. Let's take the common log. Let's see what log of 20 is. Okay, so watch. I'm going to grab my calculator. And look, log of 20, it's 1.301, roughly. Okay, 1.301. Well, would you guys agree that 20 is the same thing as 5 times 4? Absolutely it is, right? 5 times 4 is 20. Well, look, I'm just going to break this up then, all right? Log of 20, which is log of 5 times 4, is the same thing of log of 5 plus log of 4. And now check this out in your calculator. Watch what this is roughly equal to. So log of 5 plus log of 4, you get the same thing. Boom. Look, exactly the same. So what I'm saying here is this product rule absolutely works. Okay? All right, so whenever you see multiplication like this, think of it as I can break it up as addition. Okay? Next, let's talk about the quotient rule. So let's let b, m, and n be positive real numbers with b not equal to 1. If you have log base b of m divided by n, okay, that's equal to log base b of m minus log base b of n. Okay, so for example, if you have log base 6 of 10 divided by x, my m is in the numerator here, so this would be log base 6 of 10, and then minus log base 6 of x. And again, I'll just do it for this one. I'll show you that it works, right? So if you have log of 10, okay, or I'm sorry, let's do log of 15. Sorry, log of 15. What is log of 15 equal to? 1.176, roughly 1.176. Well, would you agree that this is the same thing as log of 30 over 2? Yeah, because 30 over 2 is 15. So this would be log of 30 minus, using our rule here, log of 2. And let's see if we get the same thing. And look, you get the same thing. So this rule also works, okay? So you get 1.176. All right, so what you're seeing here is product rule. You can break up as addition. Product inside a log, you can break up as the addition of two logs. Quotient inside of a log, you can break up as the difference, right? Subtraction of two logs. And then our final rule here is the power rule, okay? So let's let b and m be positive real numbers with b not equal to 1. And let's let p be any real number. If you have log base b of m raised to the p power, what you can do, what you're seeing here is you can take a power and move it in front of the log, okay, as a product. So this is equal to p times log base b of m, okay? So for example, if you have log base 5 of x cubed, this is equal to 3 times log base 5 of x. All right, and let me show you, real briefly that this works. If we were to take log of 25, let's see what that's roughly equal to. You get 1.398 when you round it, 1.398. Well, 25 is the same thing as 5 squared. Well, using our power rule, you can bring the 2 down in front. So this is 2 log of 5. And let's see if that's roughly the same thing. So 2 times log of 5. And you get the same thing. So this power rule does absolutely work. All right, so these are just really, ways to take logs with complicated expressions and break it down into many logs of simpler expressions. Okay, so these are our rules. All right, just to rehash. Log base b of m times n is log base b of m plus log base b of n. That's the product rule. If you have log base b of m divided by n, that's equal to log base b of m minus log base b of n. That's the quotient rule. And then if you have log base b of m raised to the p power, that's equal to p times log base b of m. That's the power rule. And so what we want to do here, okay, is we want to use all these rules, okay? First to expand logs, and then what we want to do is then we want to go backwards and condense logs. All right, so let me show you how to do these, okay? And we're just going to work a ton of examples. So let's use the properties of logarithms to expand each logarithmic expression as much as possible. Okay, so here would be the first one. Let's look at the natural log of e to the 4th over 8. Okay, so the first thing you're going to look at here, okay, do you notice how this is a quotient of some type? It's a quotient, okay? So the first thing you're going to do is you're going to break it up as the natural log of e to the 4th minus the natural log of 8. Nice. Well, then look here, I got this 4. Okay, so the next thing I'm going to use, I used the quotient rule. Now I'm going to use the power rule. I'm going to bring that 4 down in front. And then this is awesome. If you remember from the previous lecture, what is the natural log of e? Well, that's just 1. So this whole thing just simplifies into 4 minus the natural log of 8. Okay? And look, let's verify that. All right, just so we know that this worked. All right, so we're going to take the natural, let me clear everything. The natural log of e to the 4th, so e to the 4th, divided by 8. And we got 1.920 blah, blah, blah. So let's just see. What is 4 minus the natural log of 8? Get the same thing. So our rule, we simplified perfectly here. Okay? Let's try this one. Let's look at log base 5 of x squared times y. Well, look, I've got the product of x squared and y. So I'm going to break this up using the product rule. So this is log base 5 of x squared plus log base 5 of y. And then you can simplify this. You can take the squared and you bring it down. So this finally simplifies as 2 times log base 5 of x plus log base 5 of y. Now look, I'm going to put 2 other problems up here. Let's try this one. Let's look at just log, so it's log base 10. So log of x squared y divided by z squared. See if you can do that one. And then also, let's try this one. Let's look at the natural log of the square root of x all over, let's do 25. All right, so you know what, I'm gonna just pause the video, give these problems a shot, and then what I'm gonna do is hopefully you do that, and then I'm gonna come back and I'm gonna solve them for you. Okay. All right, so here, this one first here. First thing you're gonna do is you're gonna break up the quotient. Okay, so this is log of x squared y minus log of z squared. And then look, you're going to say inside here, look, I can break this up as log of x squared plus log of y, using that product rule, minus log of z squared. And then look, you can use the power rule finally and bring down the exponents. So this is 2 log of x plus log of y minus 2 log of z. Finally here, you can break this up. So this is the natural log of the square root of x minus the natural log of 25. And what's cool here is, watch, I can rewrite the square root of x. This is the natural log of x to the 1/2 power minus the natural log. I can write this as 5 squared. And then look, now you can use the power rule. You can bring the 1/2 down. Natural log of x minus 2 times the natural log of 5. All right, let's work on these, let's work some harder ones, okay? Ones that involve a few more steps to it, all right? All right, so let's go to the next one. Same thing. Let's use properties of logarithms to expand each of these. All right, so here'll be our 5th example. Let's look at log of the square root of xy to the 4th all over 16. All right, well, here's how I would tackle this problem. Square root. I can write this as log, and then in parentheses, xy to the 4th, 16, all to the 1/2 power, okay? Well, then what could you do next, right? You could distribute the 1/2 to everything. Or you could use your rules of logs and bring it out front if you wanted to, and then distribute it later. But I'll distribute it to everything in here. So this would be log of x to the 1/2. 4 times 1/2, this would be y squared. And then 16 to the 1/2 power, well, that would be the square root of 16, which is just 4. And then look, begin the process. This would be log of x to the 1/2 y squared minus log. I'm going to rewrite 4 as 2 squared so I can, even simplify it even more. And then look, I'm going to break this up, all right, using the product rule. So this would be log of x to the 1/2 plus log of y squared minus log of 2 squared. And then your final step is just to bring the exponents down. So this would be 1/2 log of x plus, bring the 2 down, 2 log of y minus 2 log of 2. So a lot going on here, okay? You just got to be meticulous. Take your time. Take your time. Let's try this one. It's a crazy one. Let's look at the natural log and then natural log of x to the 4th times the square root of x squared plus 3, all divided by x plus 3 to the 5th power. So look, by now hopefully you're starting to see the pattern. Break it up first using the quotient rule. So this is the natural log of x to the 4th times the square root of x squared plus 3 minus the natural log of x plus 3 to the 5th power. Break up this log using the product rule, right? So multiplication breaks up as addition of two logs. So this is the natural log of x to the 4th plus the natural log square root. I'm going to write this as x squared plus 3 to the 1/2 power minus the natural log of x plus 3 to the 5th power. And then, again, what's the last step? Boop, boop, bring down the exponents. So this is 4 natural log of x plus 1/2 the natural log of x squared plus 3 minus 5 times the natural log of x plus 3. All right. So again, just following the rules. Break it up, break it up. Now what we want to do, okay, now we talked about expanding. Now what we want to do is condensing, so going backwards, okay? So the rules work both ways, okay? So if you have log base b of m plus log base b of n, you can literally go backwards, okay? You could write this as log base b of m times n. And it's the same thing. If you have log base b of m minus log base b of n, that's just log base b of m divided by n. And then you can use the power rule. You can bring the p back up. So if you have a multiplication out front, you can bring it back up. So p times log base b of m is equal to log base b of m raised to the p power. Okay, so here's what we want to do. We want to use the properties of logarithms to condense each logarithmic expression as much as possible. All right, so let's take this one. Log of 5 plus log of 2. Well, look, they have the same base. So this is just log of 5 times 2, which would be log of 10. And then just, hopefully you remember your rules that this is going to be 1, but look, you can do log of 10. You can see right there, 1, because the bases are the same. Let's try this one. Let's look at log of 3x plus 7 minus log of x. Well, look, subtraction, I can combine this as log of 3x plus 7 minus whatever's down here. So divided by x. So I broke it up or condensed it using the quotient rule. All right, let's try this one. Let's look at 5 times log base 2 of x plus 6 times log base 2 of y. All right, so what you're going to do here, you're going to bring up using the product rule. So this is log base 2 of x to the 5th power plus log base 2 of y to the 6th power. And then look, log base 2 plus, so this just becomes log base 2 of x to the 5th times y to the 6th. We've got it. All right, let's try this one. Let's look at 1/2 and times, and then in parentheses, log of x plus log of y. All right, so look, parentheses first. This becomes the product rule. So this becomes 1/2 times log of xy. And then look, you bring up the 1/2. Well, what is 1/2 as a exponent? So this is log of xy to the 1/2 power. Well, that's the square root. So this ends up just being log of the square root of xy. All right, let's do some crazy ones here. So, you know, we'll do just like we did 2 hard ones here. Let's do two hard condensed problems. All right, let's try this. 1/3, and then in parentheses log of x minus log of y, plus 2 times log of x plus 1. All right, so look, for these harder ones, you're going to work left to right, and then always do what's inside parentheses first. All right, so this is 1/3 log. This subtraction is quotient rule, so x divided by y plus 2 times log of x plus 1. Bring up the exponents. Okay, so a 1/3 here, okay, that's the third root. So this is log of the third root of x divided by the third root of y plus log of x plus 1 squared. And then look, you're going to break up the, or condense this. The plus sign means multiplication. So when I multiply, this goes up into the numerator. So this just becomes log of third root of x times x plus 1 squared all over the third root of y. Literally like that. All right, let's try this crazy one here. Let's look at log of x plus log of x squared minus 4 minus log of 15 minus log of x plus 2. Work left to right, left to right. So first, combine these using the product rule. So this is log of x times x squared minus 4 minus log of 15 minus log of x plus 2. Keep working left to right. So quotient rule. This is equal to log of x squared minus 4 divided by, because subtraction, divided by 15, and then minus log of x plus 2. Well, look, this subtraction here, when you go to divide this, okay, divide by this, you know, take this and divide it by this, you would keep, change, flip, and this would basically just gets tucked into the denominator. So this then becomes log of x squared minus 4 factors as x minus 2, x plus 2, and you'll see why I'm doing that, divided by 15, and then times x, and then in the denominator also x plus 2. So look what cancels. So make sure you check for that when you do these problems. And we got it. All right. Last thing I want to talk about now. Then we have some idea of expanding and condensing logs. Now let's talk about change of base. And this is going to help us evaluate logs. So for any logarithmic bases a and b, okay, and any positive number m, we have the following. Log base b of m is equal to, same, and I'm going to show you that this works, is equal to log base a of m divided by log base a of b. So you can change of bases, okay? We're mostly going to use this in our calculator with these ones here. If you have log base b of m, that's equal to log of m divided by log of b. Or you can also use log base b of m is equal to ln of m divided by ln of b. Okay, let me show you why you're going to need this. Okay, suppose I ask you to evaluate the following. Let's do log base 5 of 13. I say, what is this equal to? Well, if you look at your calculator, the only things you have in your calculator are log and ln. All right, so what you can do to evaluate this is, look, this becomes log of m. So my m here is 13. So log of 13 divided by, and then going back, log of b, log of the base. So here the base is 5. And so now you can evaluate this. So this becomes log of 13 divided by log of 5. And you get 1.594 when I round it to 3 decimal places. And look, you would get the same thing if you were to do this as the natural log of 13 over the natural log of 5. So if instead you wanted to use the natural log instead, you get the same thing. Let's just do this one. This will be the last one. Let's do log base pi, that's wild, of 63. Well, look, I'm going to evaluate this as log of 63 all over the log of pi. Which you could also, again, it's literally, you're going to get the same answer if you use natural logs instead. So log of 63 divided by log, and then pi is there. Look, and then let me show you with natural logs. Again, so you get 3.619. All right, class. I hope it helps seeing these problems. You're going to get a chance to practice a lot of this in assignments. And if you have any questions, as always, just let me know. I'm always here.